Hey guys, today I'm going to be solving Leetcode problem 2130, maximum twin sum of a linked list. And so this question problem states in a linked list of size n, where n is even and the ith node, the nodes are zero indexed, of the list length is known as the twin. For example, you can see here, basically it's just mirrored. So you can see 1 is a twin of 5, 4 is a twin of 2, like, and then if there were ones on the outside, basically just a mirror image of each other. Reading at this, I don't know why this confused me, but yeah, it's just mirrored. And so what we want to do is, given the head of a linked list with an even length, so we can always assume that it's even, each node has a twin, we're just going to return the maximum twin sum. So the twin sum is going to be basically these same colored summed together. So 4 and 2 is 6, and then 5 and 1 is 6. If you come down here, example 2, we're going to add up together 2 and 2 is 4, and 4 and 3 is 7. 7 is bigger, so we return 7. And last example, there's only one set of twins here, so it's just going to be 1 plus whatever this is. I can't see 100,000, so it's going to be 100,001. And so I'm going to do the solution that I feel like was easiest for me to just naturally come up with. I know a lot of these answers involve reversing the second half of the linked list, which makes sense, and then using 2 pointers to iterate through. But when I first saw this problem, first thing that came to my mind was just using a map. So I'm going to do that solution because I think, at least for me, it was more intuitive, and it's still pretty fast. It's still a constant time. We just use some space. So I'm going to start. I'll write out the approach here. So let's do like, here we're going to do like, first step is going to be, we're going to want to iterate through list and find total number of nodes. And then, so this is going to give us the total number of nodes. And then what I did was, second step was make a map. And basically what this map is going to do is it's going to organize, basically make a key for each of the first half of the list. So in this case, it would make a key value pair for the 0th and the first index. And then when it gets to the second half of the list, and we'll know that because we know how many nodes are in the list total. Once it gets to that second half of the list, it just finds in the map the corresponding value like of its twin, and then adds it together. And then as we're making this map, we can track which key value pair has the maximum value when going through like that second half of the list. So this to me was more intuitive. It might not be for you, but I'm just going to do it this way to show you, because I think, yeah, a lot of the solutions in here use the 2-pointer way and reversing the linked list, but this way you don't even have to manipulate the linked list at all. So, okay, so yeah, I'll finish writing out the approach, make a map. It's going to be first half, we create key value pair, and then second half, add the twin, and throughout this we're gonna find the max, or we'll do like keep track of max, and this is gonna be happening like in this second step. So first, let's do the find total number of nodes, and then let's do let total is equal to 0, and then we have that head, so let's do node equals head. Okay, so now let's just simply iterate through and we'll do while the node isn't equal to null. So we'll use the 2 exclamation points here. And we're just going to increase the total. And then we're just going to say node is equal to node.next. So this is going to move through the singly linked list and keep track of the total. So that's simple enough. And now we're going to do fill out the map to keep track of twin sums. And so this one, I guess, step is a little bit more difficult, but still not too bad. So let's keep track of current is equal to head. I'm just going to name it current because I already used node here, but same concept. Then we're going to do a map. I'll just name it map. I'll just use a regular JavaScript object, and we're going to want something to keep track of the maximum twin sum, and we'll just initialize it to -infinity. So that way, anything that we see is going to be greater than it. So we're just going to make sure that any twin sum is going to be larger and get set to the max. So now let's iterate through the linked list again. So let's do while current in here. And so we're going to want a variable to keep track of like what step we're on or what index we're on for the node. Because, right, like I said, on the first half of the list, we want to make the key value pairs. The value is just going to be the value of that node. And then on the second half of that list, we're going to want to find the twin in the map and then add its value to the twin's value. So now let's do that. So we're going to look at at the end of this, let's say each time we're going to increment I, and then we're going to do current is equal to cur.next. So this is going to happen at the end of each while loop. Oops. Okay, so if we're going to do I is less than the total divided by 2, right? That means we're in the first half of the list. Then all we're going to do is we're going to do map of that index is going to be equal to the current value. So the current value of the node. So, right, that's what we're doing for the first half of the array, or the first half of linked list, and then else, this is going to be the second half of linked list. Then what we're going to do in this case is we're going to do let's find the twin. So let's do the twin is going to be equal to, right, the total number of nodes. And then we're going to do minus the index that we're on right now. And then -1. So let's look at this first example here. That means basically when we're on this second index, we know that it's going to be equal to the total number of nodes. So 4, right? There's 4 nodes here, -1, because we're on our first, or sorry, -0, because we're on our 0th iteration. So we're going to be here. And then we -1 just because it's 0 indexed. So we're going to be here instead. And then through the next iteration, when we're here at the 3rd index, we're going to do total. It's twin is going to be the total minus I. So we're on 3 -1. So it's going to be the 0th index. I think I messed up when I was saying this one, but you get the gist. Basically, yeah, we want to take the total and we want to minus or subtract the index to find the twin. Then, once we have that twin, we're going to do map of twin, because right, we already have the twin in the map ideally, or theoretically. We're just going to add the current value to it. And then we're going to say, this is where we keep track of the max. So we're going to say if map of twin, right? We just added the twins sum. If this is greater than the max, then we're just going to do max is equal to map twin. And then after this loop, right, we're increasing I and we're doing the next node, moving to the next node. So then at the end of this, we should be able to just return the max. So let's run one. Okay, so for that first example, it works. And now let's do this for the second. Okay. So yeah, you can see this solution obviously uses up space, but it still is constant time, or sorry, not constant time. It's still O of n time because we only have to iterate through the linked list twice.